Okay, so this is going to be a video about how you can look at the graph and determine the domain and the range. It's important to remember that the domain kind of covers all of the x values of the graph. And we're going to look for the domain for the x values just the way we look at the x-axis, which is from left to right. And for the range, we want to remember that the range is all the y values. And we're going to look at the range just like the way we look at the y-axis, which is from the bottom to the top. Now you might ask yourself, why does it have to be from the bottom to the top? Why can't it be from the top to the bottom? And the reason is just that we're always going to start with our lowest numbers and go to our highest numbers. So just like on the x-axis, our lowest numbers are our negative numbers over here on the left. So over here I have a graph of what kind of looks like an ellipse or an oval. And it's not a function. It doesn't pass the vertical line test, but it's a nice graph to take a look at and look at its domain and range. When I look at the left side of this graph, I notice that this ellipse stretches all the way to -4. And I have an x value here at -4. I have two x values at -3. And this graph is continuous from -4 to +4. So I can say that its domain is from -4 to +4. Now, we really wouldn't write like -4 to +4. That wouldn't be very formal. It wouldn't have good notation. So the way we're going to do that is we're going to say -4 is less than or equal to x is less than or equal to 4. And what that stands for is that all the x values between and including -4 and +4. We're going to use similar notation to find the range. Again, the range are the y values that the graph covers from the bottom to the top. I see that this ellipse goes all the way down to -1 and all the way up to 3. So its range would be -1 is less than or equal to y is less than or equal to 3. Over here on the right, we have just a graph of what would look like a line, but it's actually a line segment because we don't have arrows here, and it doesn't go all the way to the end of my grid. If the graph touches the end of the grid, we can make the assumption that that's just a computer-generated graph and that the graph would really continue going in that direction. But because this pink line segment clearly stops at a point here and then a point here, we know that this graph isn't going to go any further than these two endpoints. So looking at the range, or the domain, on the left, let's see, -1, -2, -3, -4, -5. And this graph covers everything from -5 to 1, 2, 3, 4. And notice that I'm counting right and left. Now, for the range, on the bottom, if I look at the lowest point, now even though this one was on the left, it's not the lowest point, so I'll start over here. This is the lowest point here at -1, and this graph goes all the way up to 3. And I want to point out that all my less than signs are also equal to because we're equal to. If I had changed this graph, let's say we just took this graph and we got rid of that and we made it, we'll make it in like green. An open circle here. Wow, that's really big. There we go. And then we wouldn't be including this value at 4 or at 3 because the graph would go include everything up to, but not including that point at 4. Whoops, not 3. That would still be equal to -1. Let's look at some more graphs. So here I have two computer-generated graphs. These are actually square root functions. And I want to point out something. First of all, that these graphs start at a clear point. And because they touch the end of my grid, I'm going to make the correct assumption that they continue in that direction. So let's take a look. The graph on the left starts at -3. We have a point here at -3, and I have a point everywhere to the right. So this graph is -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and it'll keep going. There are two ways to write this. One is -3 is less than or equal to x, which is less than infinity. You can put an equal to here, and most teachers won't mark it wrong. I don't like to put an equal to here because infinity is a concept. It's not something you can really touch or be, so we don't want to be equal to it. Another way you could write that would be just simply x is greater than or equal to negative 3. So looking at the range, normally we said we look from the bottom to the top. So the bottom would be over here, and this is going to go all the way down because it's on its way down. And we say the bottom of this graph is at negative infinity. So we would say negative infinity is less than or equal to y is less than or equal to 5. Okay, again, that's one way to write it. Another way to write it would just be y is greater than or equal to 5. Now this graph on the right is another absolute value graph. I'm sorry, another square root function. And it has a starting point at 4, negative 1. So when we look at the domain here, on the left, we are at negative infinity. On the right, we're at 4. Another way to write that would be x is greater than or equal to 4. For the range, this graph goes all the way down to negative 1. And all the way up to infinity. And another way to write that, of course, will be y is greater than or equal to negative 1. I have a mistake here. Who has found it? I actually have 2 mistakes here. Wow. Clearly, I have not had enough coffee today. Let's take a look. If we look at this graph, is it really everything greater than or equal to negative 3? Yep. Is it everything greater than or equal to 5? Nope. That one I didn't notice. This one, the other one I made on purpose. This was a legit mistake. So this really should be y is less than or equal to 5. Over here, this one I made on purpose. Is this everything greater than or equal to 4? No. Oh, I did it again. There we go. All right, those look better. All right, let's take a look at some more. So here I have 2 quadratic functions, 2 parabolas that I've graphed with some software. And again, because they touch the end of the graph, I'm going to put some arrows here. Now, the domain. When I look at the right side of the graph, or the left side of the graph, the arrow goes up and to the left. On the right side, it goes up and to the right. So the domain here is going to be everything between negative infinity and positive infinity. Now this is kind of a special situation. When this happens, when the endpoint of our interval are negative infinity and positive infinity and everything in between is included, we say that that's the same as all real numbers. The symbol for all real numbers looks like this. It's like a paragraph symbol, but then it's an R. Now, if we look at the second quadratic graph, we have the same situation. Just because the graph is going down, it's going down and all the way eventually to the left. Like it could be like shh and keep going. So it's going to go down and to the left and then down and to the right. It means we have another domain of all real numbers. Let's look at the range. The bottom of the left graph is at negative 3 and the top of the graph is at infinity. So we've got negative 3 is less than or equal to y is less than infinity. Another way to write that would just be y is greater than or equal to negative 3. Now for the other graph, its arrows go down. It starts actually at negative infinity and goes up to negative 1. So negative infinity is less than y is less than or equal to negative 1. And another way to write that could just be y is less than or equal to negative 1. Okay, now we have 2 graphs that are really similar to quadratic graphs. We have 2 absolute value graphs. Okay, and again, they touch the end, so we're going to make the assumption that there are arrows. I want you to take a second and predict what you think the domain and the range of these 2 functions are. Go ahead and pause the video. All right, if you said the domain of both functions is all real numbers, you are correct. Now, if you said the range of the first graph is everything higher than or including 2, you are correct. other graph is actually everything less than or equal to 2. Now let's take a look at these for a second. They both have a special point called a vertex. The fact that this vertex is at 4 and this vertex is at -1, those are interesting facts, but they don't really affect our domain and range. So just be careful. Some people see this point at 4 and they want to put it somewhere in the domain or range. And that's just the vertex point of our graph. It doesn't have anything to do with what values the graph will cover. All right. I have two more examples for you. These are two special cases. The first one is just a line. It could be like the line, it's in the form y equals mx plus b. If I look at it, it looks like it might be, this looks like about 2.5. Let's see if we can figure out this. It looks like it has a slope of 1/2. I think this is the line y equals 1/2 x plus 2.5. Okay. Now, its domain and range, what do you think about those? When we look from left to right, what do we notice? And from bottom to top, what do we notice? We notice that it covers everything. So the domain is all real numbers, and the range is all real numbers. Then we have this interesting little graph over here, and this graph is something special that none of the others are, and that is this is a discontinuous graph. We say it's discontinuous because as you're traveling along the graph, over here at the x value of 2, it jumps. We have an open circle here, and then we have a closed circle here. So what x values does this graph cover? Do you have an x value at, I don't know what this is, here, we'll just say here. Here, here, yes, here, yes, 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 yes. Ooh. We have an x value here. It's just up here, not there. So we actually have an x value everywhere. So we're going to say the domain is all real numbers. Now what's weird about this is the range. We have two horizontal segments. Okay. What y values do you think this graph covers? If you were just going to say it in words, what are the y values it covers? Covers 2 and 4. That's it. Nothing else. That's just a really big fat point because I just made it like a big fatty point. This graph only has two y values. It's not from 2 to 4. It's not 2 is less than or equal to y is less than or equal to 4. It's only 2 and 4. So we're going to write that using a set. 2, 4. Just those two integers. So that one's a little special. Hope you found this video to be helpful. Sorry about the little mistakes on the second page. Just coming off summer vacation, so it happens. Thanks.